Here's a general question for you. Is writing a multi-threaded, high-concurrency application easy, or would you say it's hard? I'm pretty sure I know how most of you would answer this question. It's typically really hard, and there are dangerous pitfalls at every corner in a high-concurrency, multi-threaded application. So what is it that makes writing multi-threaded applications so hard? Well, there are plenty of things, but way up there at the top of the list of challenges would be the following. First of all, most languages that have threads offer shared memory between the threads. So what's the problem with shared memory? Well, when there's shared memory between threads, there's a big risk that two or more threads will try and mutate and or read that memory at about the same time, which could result in either reading memory that's in the middle of being mutated. In other words, the memory is not in a consistent usable state, or you could end up with memory corruption or lost data when multiple threads try and mutate the same data in memory at the same time. So what's a programmer to do in these types of situations? Well, we often introduce locks of one sort or another that limit memory access to only a single thread at a time, which can solve one problem, and it can introduce other problems like deadlocks and live locks and other related problems. And even if you don't run into problems like deadlocks when using memory locking mechanisms, you're introducing bottlenecks in your application, which sort of defeats the purpose of multi-threading, at least in part. Another common problem with multi-threaded programming is the fact that threads, in most popular programming languages, are pretty heavyweight. What do I mean by heavyweight? Well, depending on the environment, each thread you create takes at a minimum 1 to 3 megabytes of memory, and often much more. And the worst part of these heavy threads is that most of the time, the threads aren't doing useful work. They're just consuming valuable resources while waiting on slow I/O operations like talking to a database or making an API call. By the way, in everything I just described, I'm mostly referring to concurrent programming where each thread is serving separate and often totally unrelated requests. Now, things get even more challenging if you're wanting to achieve parallelism. For example, if you're wanting to solve a single problem by distributing the work across multiple threads in order to leverage multiple CPUs. So why is it that concurrent multi-threaded programming is such a pain in most programming languages? Well, I think it's because most programming languages weren't designed from the ground up to support concurrency. In fact, I'd say the concurrency features in most programming languages is sort of an afterthought, or a set of features that is secondary to sequential programming. Now, as you'll recall, Elixir runs on the Beam virtual machine, which is the runtime that was originally created for Erlang. Erlang was designed with different priorities, pressures, and constraints when compared to pretty much every other language. What do I mean by this? Well, Erlang was created by the folks at Ericsson many years ago, and they didn't have the goal of creating another general-purpose language. Okay, well, why was that? I mean, if you're going to create a programming language, wouldn't you like a lot of people to use it? And wouldn't making a general-purpose programming language get lots of people to use it? Well, if a general-purpose programming language would have solved Ericsson's problems, they wouldn't have needed to create a language. They could have just used one of the existing programming languages. But pretty much all general-purpose programming languages are sequential programming languages. But Ericsson's problems were challenges with high concurrency, which isn't solved well with sequential programming languages. So what exactly was Ericsson's problem? Well, they created telephone switches, and they had to control many concurrent phone calls on the hardware that existed several decades ago. Now, not only did Ericsson have high concurrency challenges, they also had interesting financial risks associated with their service agreements. What do I mean by financial risks? Well, they had service-level agreements with their customers that cost Ericsson dearly if and when there were small outages. So because of these challenges, Erlang and the Beam were born, and pretty much every design decision that was made when building Erlang revolved around the needs of high concurrency, fault tolerance, and distributed computing. By the way, these are some of the same challenges we face as web developers. So what did the creators of Erlang do to solve these problems? Well, they did quite a few things, such as eliminating shared memory and eliminating mutations and limiting the effects of errors and much more. And to achieve these goals, the folks at Ericsson redefined the basic primitive for doing work. In other words, they said threads, as implemented in popular programming languages, just wouldn't work well, so instead they created a different primitive for doing work, which is called a process. But this isn't a process like you may have heard of from other languages. The characteristics of an Elixir process are quite different from processes and threads from other languages, and that's what we'll start to look at in the next video.